So, and that is all for psi equals 1. Try to satisfy boundary conditions and get expression for psi that depends on B0, B1, B2, and P critical L square. So that's later we can try to obtain the buckling load. Just to find psi is much work. Maple or MATLAB. So I sent by Blackboard announcement that this Wednesday, coming Wednesday, there will be the retake. Who is going to take retake? 1, 2, 3. Okay. And I think there is one more person. So that means that other people do not have to come. And that will be here and conducted by 2 people of mine. One, my PhD graduate, very recent, and second, he does not know yet. I will ask also Mr. Duja to be present during that retake. I will not be here during that retake. But I will prepare this and they will give you the test. Any questions until here? Any questions on this assignment? It is extremely good to be good in Maple or MATLAB or both. Yes, but I will need them back. But I can give you. Can you copy and give me back? Okay. Yes. Including homeworks you want? Including homework assignment pages? Yeah. No problem, I'll give you. So I will continue. Yes. It was 41. Euler's solutions. I did not finish yet. Euler's solutions are as follows. 41. That was by the request of one of the students. He came to me specially and said, can I have Euler solutions? I said, I did not write the solutions in my book. So he said, can you find them? Yes, I found. Look, please, you may want to write down. These are Euler solutions. 1759. Actually, it's exactly 250 years ago. 250 years ago. Okay, so I of x modulus of moment of inertia equals I sub 0 x over b in power m. So he deals, of course, with simply supported boundary conditions. So EI sub 0 x over b in power m, and this is y in second derivative of y, plus py equals 0.
What's b?
B some parameter. B can be L, for example, just any parameter. I will write down this equation, okay? I will rewrite this. It says E I sub 0 x over b in power m y second or w second derivative plus p critical w equals 0. That is this equation. Oh, I had y and then I changed it to w. Maybe that is what. I didn't know. So y such a. Okay, if m equals 1, solution is very difficult, then it is not obtained by Euler. Bessel functions. Not by Euler. Euler obtained for m equals 2 and m equals 4. m equals 2 and m equals 4. But solution is written in terms of some special functions. I1 and N1. So you may want to write square root of x, A1, I1, square root of 4p bx over EI0 plus b of N1, 4p bx EI0. These are Bessel functions. M equals 2. So that was not obtained by him. It was obtained much later, maybe 100 years later. But Euler's solution is this. EI0 x over b squared w second derivative plus pw equals 0. Solution is in terms of elementary functions. That is some constant cosine mu logarithm x over b plus the sine mu logarithm x of b. Okay, so that is this type of expression. Mu square equals pb square over ei sub 0 minus 1/4. So C and D are constants of integration. I just bring you m equals 1, 2, 3, 4, and that is it. M equals 3, also Bessel functions. So I1z plus N1z, z equals 4pb cubed ei 0 times x. Oh. I forgot. Oh, Zoom is here actually. Can you help me here? Please. Sorry, that is a curiosity too.
Yeah, you're turning it on and off too fast. Yeah, it takes a second to boot up.
Oh, I see. Well, at least someone tells me I'm very fast. Thank you for the compliment.
Yeah,
Thank you.
No problem. And then your Zooms are here.
Yes, Zoom are here. Yes, yes, yes. So these are Bessel functions. Now m equals 4. EI0 x over b 4 w second derivative plus p critical w. So then this is w equals x times cosine u over x plus b sine u over x. And u square equals pb in fourth power ei sub 0. See, Euler was a very clever guy. I mean, obtained first of all, he obtained only elementary solutions that exist and obtained already immediately. And he did not obtain what he did not know, but also did not exist at that time, but also what he did not know cannot be obtained elementarily. It needs more complicated functions. So that is his Bessel functions, etc. So this is Euler's solutions. So we can actually summarize if you want somewhat. So Euler obtained in 1759, then Engesser, 1899, then solution that was obtained by Duncan, 1937. This solution was independently given Zhanitsin, 1951. Okay, this solution. And then solutions that I described is 1999. And that is P critical equals minus 12 B2 over L squared. And psi of psi equals psi minus 2 psi cubed plus psi in fourth power. But also we gave here some general method. Of obtaining solutions. So this is summarized in a book that I can put here, you can write it down. Yeah, but okay, that's what we want to write. Eigenvalues of inhomogeneous structures. Eigenvalues means vibration and buckling.
Professor, could you check and see if the wireless mic is on? We're not picking you up.
It was out all the time. It was.
No, I was getting you on the desk, Mike. Well, when you walked away, I lost you.
Oh, I see.
We've got you now if you need it.
Okay, thank you. So it was not on actually. We chose that it is good to get up and walk a bit, then we find what is happening. I would like to tell you that this book is dedicated, I mean it has a dedication, and I would like to read you the dedication. Oh, if I will succeed. Oh, I did succeed. So dedicated to IFMA, which is French Institute of Advanced Mechanics, France, whose superbly educated engineers have been most instrumental in helping to bring this book to fruition. Without their dedication, it would take many more years to achieve this humble goal of communicating to the engineers, scientists, and students the infinite number of closed-form solutions. Okay, I had at different times 5 engineers from that place, and we worked on these topics. 5 different people. Any questions? Say it again. Oh, you have some questions about homeworks. Okay, we will finish and we will discuss after that. Next time we will deal with vibration. So as you paid an attention here, in buckling there were some solutions obtained prior, but in vibrations Euler did not do and no one else did either for all these years. In vibrations also one can obtain closed form solutions. It's a bit more complicated. There d of psi is not a second order polynomial but a bit higher order polynomial. Any questions? Okay, thank you, and we will discuss the questions if you have about homeworks. So you want these pages?
Yes,
please take and return them to me, okay?
Huh?
Oh, okay, next Monday.
Okay. All right.
Next Monday, not now. And I will sit,
Huh?
I will, no, it was published a couple of years ago. Couple of years ago. So there will be several people coming, yes?
Yes.
3 from here and 1 more from, okay, thank you.